In episode 43, titled IaC and Configuration Findings, we focus on a reality of modern environments that never goes out of style. Most breaches do not start with cinematic hacking, they start with a setting. Configuration mistakes are how secure components become exposed components, especially when infrastructure is created quickly, replicated widely, and changed by many hands. The hard part is that a misconfiguration often looks like a normal choice until you view it from an attacker's angle, where reachable, permissive, and default can quietly translate into exploitable. This episode builds a practical way to recognize configuration risk early, reason about it clearly, and communicate it professionally. If you can connect a setting to an exposure and then to an access path, you can explain real risk without speculation or drama. Infrastructure as code is the starting point because it describes how many organizations now build networks and services. Instead of clicking through consoles by hand, teams define templates that declare what should exist, such as virtual networks, subnets, routing rules, load balancers, storage resources, and service identities. Those templates can be versioned, reviewed, and reused, which is a major improvement over undocumented manual work. The security implication is that the template becomes a powerful source of truth because one unsafe pattern can be stamped out across many environments. It also means changes can be fast, and speed is great until it turns small mistakes into widespread exposure. When you evaluate IaC, you are evaluating both the intended design and the habit of encoding decisions into repeatable blueprints. Misconfiguration is easiest to explain plainly. Unsafe settings make services reachable when they should not be, or permissive when they should be constrained. Reachability is about exposure surfaces like public addresses, open inbound rules, or permissive routing that turns internal services into internet-facing targets. Permissiveness is about permissions, such as identities that can do more than necessary, policies that match all resources, or roles that grant administrative actions by default. Many misconfigurations are not wrong in a technical sense because systems will still operate, and that is why they persist. They are wrong in a risk sense because they expand the set of things an attacker can touch and the set of actions an attacker can perform. The exam mindset you want is to translate works into works safely, and to recognize when a setting makes that translation fail. Common findings show up so often that you should be able to spot them almost on reflex. Open security groups or firewall rules that allow broad inbound access, such as any source, to sensitive ports are an evergreen issue because they provide a direct entry point. Public storage exposure is another, where buckets, blobs, or file shares are readable or writable from the internet due to permissive access controls or inherited policies. Weak identity policies round out the trio, including overly broad roles, permissive trust relationships, and policies that grant wildcard actions or resources. These problems are popular with attackers because they are low friction. There is no need to exploit complex vulnerabilities if a door is already open. In assessments, you should treat these as high-signal indicators that other adjacent issues may exist, because risky defaults tend to cluster. Drift is the concept that explains why a clean template can still result in a messy environment. Over time, real settings diverge from templates due to emergency changes, troubleshooting tweaks, one-off exceptions, or manual edits that bypass the normal pipeline. Drift also appears when teams apply a template once and then continue making changes through a different mechanism, leaving the code behind as an outdated snapshot. The security impact is twofold. First, the environment may be less secure than the template suggests, and second, teams may believe they are compliant with their own standards because the code looks good. Drift is also a source of uncertainty during validation because you cannot assume the declared state equals the actual state. When you understand drift, you stop arguing about what should exist and start confirming what does exist. Small configuration gaps rarely stay small because systems are interconnected and attackers chain opportunities together. One gap might provide reachability, another might provide authentication weakness, and a third might provide privilege escalation, and each gap makes the next one more valuable. For example, an internal administrative interface might not seem dangerous if it is only internal, but it becomes dangerous if network rules expose it, or if an identity policy allows a service account to query it. Similarly, a storage resource might be private, but if a compute role can list and read it broadly, a compromise of that compute service becomes a data compromise. Chaining is not about flashy techniques. It is about moving through the environment in the same way legitimate workflows move, but with hostile intent. The practical skill is to see how settings compose into access paths rather than evaluating each setting in isolation. Consider a scenario where a public service combined with a weak role creates escalation, because it captures the essence of how these issues play out. Imagine a web service deployed with a public endpoint, intended to be reachable, but running with an identity that has broad permissions to manage infrastructure resources. The public exposure increases the chance of compromise, whether through credential reuse, application flaws, or simply misused administrative features. And once compromised, the service's role becomes the attacker's role. If that role can modify security groups, update access policies, or assume other roles, the attacker can expand reach and privileges quickly. The escalation is not magic. It is the environment behaving exactly as configured, just with the wrong party driving it. When you articulate risk this way, you are not guessing about attacker capability. You are reading the consequences of the permissions model. Safe validation is how you confirm reachability and permissions without becoming the source of an outage. Reachability can often be verified through passive evidence, such as configuration state, routing, and exposure settings, rather than aggressive probing that could stress a service. Permission validation should focus on what the identity is allowed to do and how that permission is obtained, without attempting destructive actions or changes. A careful validator confirms whether an identity can list resources, read sensitive configuration, or perform administrative operations, but does so in a way that avoids altering real infrastructure. The key is to separate "can this happen" from "let's make it happen," because the first can usually be demonstrated with policy analysis and non-disruptive checks. Professionalism here is not just etiquette, it is risk management, because availability is part of security. Remediation should be framed as tightening defaults, adding guardrails, and enforcing reviews, because those are sustainable changes that reduce recurrence. Tightening defaults means making the safe choice the easy choice, such as defaulting to private access, least privilege roles, and restricted inbound rules unless there is an explicit exception. Guardrails include policy constraints, automated checks, and deployment controls that prevent risky patterns from being introduced in the first place. Enforced reviews are the human layer, where changes to templates and critical configurations require eyes that understand both the technical intent and the security impact. A strong remediation plan does not just patch the one instance you found, it changes the system so the same mistake is harder to repeat. On an exam, look for answers that improve the process, not just the symptom. Reporting language matters because configuration findings often live or die on clarity. A strong report shows the specific setting, explains the exposure that results from it, and proposes a recommended safe value or safer pattern. The setting is the evidence, the exposure is the impact, and the recommended value is the path to resolution, and your wording should connect those cleanly. Avoid vague phrases that sound like opinions, and instead describe what is true in the environment and what that truth allows. If a security group allows inbound access from any source to an administrative port, say that plainly and state why it increases risk. When you write this way, stakeholders can act on the finding, and defenders can verify the fix without guessing what you meant.
A common pitfall is focusing only on one setting and missing the adjacent dependencies that make the risk real.
For example, you might fix an inbound rule but miss that the service is still public through a different route, such as another load balancer, a secondary network interface, or a permissive routing path.
You might tighten a role policy but miss that another identity can assume the same role, keeping the escalation path alive.
You might lock down storage access but leave public listing enabled, or allow a different service to exfiltrate the same data through broad read permissions. Configuration is relational. Settings interact, and the risk often sits in the intersection.
The disciplined approach is to check the neighbors of a risky setting, including identity trust, network paths, and resource dependencies, because attackers will.
Quick wins are about prioritization, and in most environments, the fastest risk reduction comes from fixing overly broad access and public exposure first. Public exposure increases attacker opportunity, and overly broad access increases attacker payoff, so the combination is especially urgent. That means you triage internet-facing administrative surfaces, storage resources with public access, and identities that can make wide-impact changes across the environment.
You also look for wildcard permissions and any source network rules, because they are usually easy to narrow without breaking core functionality when done thoughtfully.
Quick wins should be safe and reversible, like tightening a rule scope, restricting a port, or replacing an overly broad role with a constrained one. Done well, these changes buy time for deeper architectural improvements without leaving the environment wide open. To keep your thinking consistent, use a simple memory phrase: setting, exposure, chain, validate, harden. Setting is the exact configuration choice you observe, not a vague category, because precision builds credibility. Exposure is the resulting reachable surface or permission scope that changes the environment's risk. Chain is how that exposure combines with other gaps to produce an access path, because real compromise is rarely single step. Validate is confirming the conditions safely and accurately, resisting the urge to prove it through disruptive actions. Harden is the remediation mindset that makes the safer pattern durable, not just corrected once. To wrap up episode 43, titled IaC and Configuration Findings, keep configuration thinking grounded in cause and effect. A declared setting creates an exposure. Exposures compose into chains, and chains become incidents when an attacker finds them first. The best practitioners stay calm and specific, because configuration problems are usually fixable once everyone agrees on what is actually true. If you had to add one guardrail to reduce recurrence, choose something that prevents the highest risk patterns from shipping, such as a control that blocks public exposure unless an explicit exception is documented and reviewed. A guardrail like that reduces both reachability mistakes and the temptation to just open it for now, which is how drift and risk often begin. When you build environments with safe defaults, enforceable constraints, and consistent reviews, you turn configuration from a recurring fire drill into a manageable engineering discipline. And that is exactly the mindset Pentest Plus expects you to demonstrate. Not just spotting issues, but understanding how modern infrastructure turns settings into security outcomes.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.